are what I choose from, when I create the final exam for you. So obviously no surprises as far as the questions go. Um, but what I wanted to do today was actually a little bit different. Let me open up this one here. So I'm actually going to have, this whiteboard app kind of thing that I would like to use. So that way I can actually see what you guys are working on. So let me send you a link for this whiteboard. And I'm not sure, you might have to be on a laptop for that. I'm not sure how it looks like on a tablet or a phone, but you should see that link coming through chat on Zoom. Okay, let me share my screen here with you guys. So the idea today is, last time I was kind of going over the questions with you and showing you how to do, but today what I want to see is how you guys would solve these problems. So how would you, tackle something? So let's get into our practice here. Okay, I believe this is from chapter 3, that last section where we talked about the rational function. So this one is asking you to find the domain. So let's go ahead. And they're asking you for the domain of f of x equals negative x over x squared minus 64. So you should be able to see that come through on your own whiteboards, and I can see you guys are in there. So the question here is, and you guys are going to guide me through this, how do you find the domain for a function like this? What's your process? Okay, Misael, did that not come down to you? There we go. Alrighty. So negative x on the numerator, x squared minus 64 on the denominator. How do you find the domain for this function?
Well, wouldn't you just assume at first it's all real numbers, and then you'd have to go in and find the vertical and horizontal asymptotes?
So for the domain, you don't have to do the horizontal ones, just the vertical. Very nice, Sohani. Because yeah, like Sohani said, you can assume it's all real numbers, but then remember there are going to be some restrictions, some numbers which you will not be able to use, and you need to figure out, what those numbers are going to be. Sarah, very nice. Figure out what would be 0 on the bottom. Kayla, I can see you took your denominator and you're trying to solve that. Okay, very nice. Okay, so Sarah and Kayla, you guys seem to be almost there. So can you write down and show me what your domain would look like once you put it in that interval notation? Tiffany, that's okay, not a problem. Okay, Misael, very good. Okay, so let's see. Misael, very good. You're factoring that out. That also works. Very nice. So let me see if I can share Kayla's board with you guys. I don't know if it lets me share a student's board or not. Okay. I don't know if you guys are able to see my screen or not, but as you can see, Kayla actually took the denominator, because remember, it's the denominator which makes a difference to your domain. So you take the denominator, x squared minus 64, and like Kayla did, where she is, using the square root property to solve for x, so you got plus or minus 8, and that's very, very important to remember. Anytime you start by taking a square root on a number, remember you get one positive root and one negative root. Or you can do what Misael was kind of working on, which is where he factored x squared minus 64. So that factors into x minus 8 and x plus 8. And then this is where you take each factor and set it equal to 0. Yeah, very nice, Misael. And you get, again, the same values of positive 8 and negative 8. So the idea is there are two numbers which is going to make your denominator 0. And so, because, think about it, if your x value is going to be positive 8 or negative 8, that means in my denominator, if I have negative 8 squared minus 64, that would of course give us negative 8 squared would become 64, and subtracting 64 from it would give us 0. So that would make your denominator 0. Same thing with positive 8. If you take positive 8 squared minus 64, you get the same result. And then of course you will see those are the two numbers we cannot include in our domain. So like Sarah had it, this is how you would end up writing your domain. Every other real number is okay, except you cannot use negative 8 or positive 8. So again, for the domain, you are going from negative infinity, you stop at negative 8. Everything between negative 8 and positive 8 is okay. And then you need to go on the other side of 8 all the way to positive infinity. And sometimes it might help to draw a number line. So you can do, let me change my color here a little bit. Okay. I guess I'm going to squeeze it in here. So if this is our number line, we're basically saying negative 8 and positive 8 are not okay. But then we are saying everything else is completely fine. So, everything from negative infinity to negative 8, which is what we had here, like I said, everything between -8 and +8, which is what we have in the middle. And then from +8 all the way to positive infinity, that would be over here. So that's kind of how you need to break this down. And if visualization helps you, draw a number line, mark the values that you cannot use for X, and that can also help you break down what your interval notation will end up looking like. So coming back to our answer over here, you are looking at -infinity to -8, again, parentheses, union, we go from -8 to +8 with parentheses, union again, and then from +8 to positive infinity. And if you remember last time also, I was telling you, practice a little bit with those domain and range questions, because for different functions, those questions can still pop up on the final exam as well.
I have a question.
Yeah, sure.
How would you find the range for that?
The range of this, I would say probably graph it to get a better idea of what the function looks like, because just by looking at the equation itself, Kayla, you would have to otherwise, do kind of a table with different y values to see in what direction, those arms are headed. But I think the easiest way would be to try and graph it and see what the function is behaving like. Okay, yeah, very nice. Good question. So we're getting into a word problem here, guys. And this one actually is also coming from chapter 3, because remember in chapter 3, we talked about the maximum value, the minimum value, where the function is increasing, where it's decreasing, of course, the vertex of the parabola and all of those different characteristics. So again, that was kind of the beginning of chapter 3. So that is where this example is coming from. And I'll try to make it a little bit bigger, so hopefully you guys can read this a little bit better. So this one is saying if an archer shoots an arrow straight upward with an initial velocity of 160 feet per second from a height of 8 feet, then its height above the ground in feet at time t seconds is given by this function over here. So you will see we are starting at 8 feet. So that's where this 8 is coming from when they told us, we were at a height of 8 feet. The initial velocity for that arrow was 160 feet per second. So that's where that 160 is coming from. And does anybody remember what this -16 represents?
Is that gravity?
That is gravity, because anything that goes up, remember, will fall back down. So that -16 is actually coming from -32 divided by 2, because that arrow will come back and hit the ground, obviously. So this is the function that you are working with, and of course they are asking us to find the maximum height which would be reached by the arrow. So basically the idea is, the archer, and this is going to be a really bad drawing, but just to kind of give you an idea. So if this is ground level, the archer is at a height of 8 feet. And, basically the idea is the arrow, as it shoots up, will reach its maximum height, and then it will come back down and hit the ground. So the first thing they want to know is what will that maximum height be that the arrow reaches? And then the second part is how long will it take for the arrow to reach back to the ground? So can you tell me for part A what we will need to do? How do you find the maximum height that the arrow reaches? So while you're thinking about that, I'm going to go ahead and copy over our formula onto our whiteboard over here. There we go. Okay. Okay, hopefully you should see that equation coming through on your whiteboards now. So remember here, guys, in this equation, the t represents the time in seconds, and h, of course, is the height for the arrow that it will reach. So part A is asking us to find the maximum height. And part B, time when it reaches the ground. Oh, sorry, Colton, you were starting to write and I just pushed something through. I apologize. So what do you think you will need to do here to find that maximum height? Colton, very nice. Sarah, alrighty. So Colton and Sarah, by using this formula, technically, what are you finding?
Finding the time.
The time, and the time will help you find the height, right? Yeah, so
Yeah.
what you are actually finding, very good, Colton, is you're actually finding the vertex that the arrow makes a parabola technically, right? Because it shoots up in the air, gets to its maximum height and falls back down. So you're actually finding the vertex because, you know, this is a parabola that's turned upside down. So that's why you're going to have that maximum height, because remember, that's the maximum value of your function. So that's kind of how all of this is tying in. So you're finding the vertex, and Colton, you're still working on it, but I'm just going to share your screen over here. So basically, you can see we're using the formula for the standard form of the parabola equation where, you know, you have x equals negative b over 2a. In this case, your x is the t variable, the time. So you can see how Colton has set it up as t equals negative b over 2a. Your negative b value, of course, is going to be negative with the 160 from the middle term, and then divided by 2a. So 2, of course, constant, and then your a value is negative 16. So you end up with negative 16 over negative 32. The two negatives become a positive, and then, you know, of course, all you are doing is dividing 160 by 32. And I believe that's where that 5-second came from. Very nice. And then as you can see Colton working, you're taking that 5-second and you're putting it back into your h of t equation where you replace your t value with that number 5, and, you know, solving that equation will end up giving you, of course, your height, the maximum height. And I believe, Sarah, you had already calculated that. And so you can see here, Sarah did the same thing, negative 60 divided by 2 times negative 16, which gave you 5, and then put it back into the equation. And that's where you got your 408. And that's going to be the maximum height that the arrow reaches. So again, as I was saying, you're basically finding the vertex for, and I'm going to change my color here again. So basically you're finding the vertex where you're trying to find the t value and the h value. Again, t is time, h is height. Your t is negative b over 2a, which is where you saw how Colton had done that. So it takes 5 seconds for the arrow to reach maximum height, and then putting this back into your equation, will end up giving you 408, I believe is what Sarah you had. And this was in feet. Yeah. So the height isn't going to be in feet. So that's all you have to do as far as that first part goes. So that's your 408 feet. Now, can you tell me what calculation you will use to find how long it takes for the arrow to reach the ground? So we know it takes 5 seconds to get to that maximum height because, you know, we just calculated that maximum height of our parabola. So then how much longer is it going to take for the arrow to reach the ground? So how are you going to find that, guys?
Quadratic formula.
Quadratic formula, okay. What would you set your equation equal to find the to use the quadratic formula, sorry.
And you set it equal to 0.
And why are we doing that, Colton?
Honestly, I can't remember.
Okay, so let's think about that. And I'm glad, Colton, that you don't know the answer because that's okay. Sometimes we don't realize why we're doing things. So when you are talking about the arrow reaching the ground, at what height is your arrow going to be once it reaches the ground?
0 feet.
Exactly. That's the reason why you take your equation and set it equal to 0. All righty, very good. So let's do a little separation over here. So you're basically saying when the arrow reaches the ground, that means your height is going to be at 0 feet. So that's why you are taking this equation and setting it equal to 0. And then like Colton said, you can use the quadratic formula to solve this because it will give you the time it takes for the arrow to reach that 0 feet. So let me see what kind of t values you are coming up with. And does anybody remember what the quadratic formula is? All right, very nice, Kayla. So perfect. You've got negative b plus or minus, and then inside the square root, you have b squared minus 4ac, and you divide the whole thing by 2a. Perfect. So I'm going to go ahead and write that down over here. So t equals negative b plus or minus square root b squared minus 4ac, and then the whole thing divided by 2a. And then of course, remember, these are your a, b, and c terms. And you take the sign of the number with the number. And so, you know, obviously, because this is, again, you can see with that square root, you have that plus or minus in front of it. You are going to come up with 2 answers, and then you're going to have to decide which one of those 2 answers makes more sense, you know, as the answer for this question. So let me see what your answers come out to be for your height in this case. So remember, it's taking you 5 seconds to reach to the maximum height of the arrow. And then, it's going to start falling down. So that should kind of help you in deciding which one would be the right, number to work with. Okay, Sarah, do you have your final answer? And then I'm not seeing any kind of activity from Connor, Ilyas, Suhani, Misael. Okay, Colton, very nice. I see an answer coming up. All righty, very nice. I can see Kayla, looks like you are done with that. So very good. Again, if you guys are able to see my screen, I'm sharing Kayla's screen over here. So you took your quadratic formula. So you've got -60 plus or minus inside the square root. We have 160 squared minus 4 times -16 times 8 for that 4AC part. And then you're dividing it by 2 times -16. Cleaning up, inside the square root, looks like you got 26,112. You've got -60 on the outside, and then of course we're dividing by -32, and then with the plus or minus. So because of that plus or minus sign that you have in front of the square root, you come up with two different answers. So with the minus sign, you actually get the 10 point, and looks like you rounded it to 2 decimal places, Kayla. You ended up with 10.049, which will round up to 10.05 or 10.1, depending on what the rounding rules are. We can go and check that. With the plus sign that you do, that is where you're actually getting this negative answer, -0.049. And again, if you round it to 2 decimal places, that would be a -0.05. But think about it, you've shot the arrow, it reaches its maximum height and hits the ground. So it's not possible for your time to be a negative number. So, obviously that means you will be discarding that, and the 10.05 seconds is going to be the right answer. And it makes sense because, again, as I was saying, if it's taking you 5 seconds to reach the maximum height, it's going to take you a little bit more time to come back down, to the ground level. So yeah, definitely something more than 5 seconds is what your answer should be. So let's take a look at what our rounding rules are. So actually it does say 2 decimal places. So 10.05 will work for us perfectly. Sarah, I think I saw 10.477 at yours. So you're off by your seconds a little bit. So I'm not sure what happened there with your calculations. Michael, you've got 10.05. Colton, you've got 10.05. Those look good. For those of you who did not have an answer, I hope you at least kind of are following along and you can see what you need to do in this example. So do keep in mind that you will see application problems on your final exam also, and we have different sections where we have talked about, just how to use the concept that you have learned from college algebra into, these application situations. This is coming from chapter 5, section 2, because remember, this is where we talked about the system of equations with 3 equations, the 3-dimensional plots where we were talking about those planes, intersecting with each other. So this is the idea we use where they're asking us to use the system of equations to find the parabola. And your parabola equation, of course, is going to be in the form y equals ax squared plus bx plus c in the standard form using these 3 equations. So can anybody tell me what we will need to do for this example? And I'll copy this over to our whiteboard. Where do you start with this? Because, we need to come up with those system of equations before we can, start finding the values over here. So how do we come up with those 3 initial equations that we will need to solve?
Wouldn't you put negative 46 as your y value equal to 4 substituting for x?
Very nice. Yeah, very good. That's exactly what you need to do, because you will see we have 3 different ordered pairs, and those 3 different ordered pairs will give us 3 different equations. All right, perfect. So we've got -4, -14. And then we had 3 and I think -28. You know what? Let's go ahead and do your equation. So basically, what we are saying is this is your x and y value for each of these ordered pairs. So for the first equation, like you mentioned, we will go ahead and do -46 for the y value, and you're using the same equation format over here. So each of the y values gets replaced with, the y from your ordered pairs, and then the x value gets replaced with the x from your ordered pair. So using the first equation, or the first ordered pair, sorry, you have -46 equals a times 4 squared plus b times 4 plus c, and of course this will then clean up into, -46 here. 4 squared would give us 16, so this becomes 16a plus 4b plus c. So this will be your first equation. And then using the same idea and the other 2 ordered pairs, you need to come up with those equations. So you need to find what your second and your third equation is going to be. So let me see what you guys are coming up with for the second and the third equation. And however you are comfortable with, you can work with that. I normally prefer having my ax squared bx plus c on the left-hand side and -46 on the right-hand side. So if that's the format visually you prefer, you can obviously rewrite your equation in that form. So what will your second and your third equation look like? Okay, very good. Kayla, that looks good. Elias, if you think about this, looks like you've got -16 on your, a times x square value, but if your x value is going to be -4, then remember -4 squared, negative and negative will become positive. So you should actually not have a negative on your 16. But of course, that negative sign will make a difference for the middle term, but not the leading term, because the x square, takes care of your negative sign. So Ms. Sayel, so you've got 16a, but then again, since that is a -4, it will affect your middle term. So it should not be positive 4b on that one. So let me see. Colton, that looks good. Kayla, yours looks good. Very nice. Michael, that looks good. And then Sarah, if you will just go ahead and put down your answer after you've simplified those square values. So Hani, very good. And then let's see what you guys have for equation number 3. That's a +3 for that third one. So Kayla, that looks good. Misael, your third equation looks good. You still need to fix your second one. Yeah, there you go. All right, very good, Sarah. Very nice. Elias, that looks good. Okay, Connor, yeah, just go ahead and simplify your square terms and you should be on your way. So Hani, that looks good. Michael, that looks good. Only thing, remember your last term should be a C value and not a B. I think you just copied the B, naturally, but that last one should be a C and you're good to go. All righty, perfect. So you can see that's how these 3 equations come up, for your system of equations by using those individual ordered pairs. So let's see, you guys had 16a minus 4b plus c equals -14 for the second one, 9a plus 3b plus c equals -28. So this will now become your system of equations. And then this is where, then you start thinking about, okay, so which variable do I want to eliminate? Do I want to eliminate A, B, or C? Which one is going to be the easiest one to get rid of? Because remember, you start out, oops, didn't mean to do that, sorry. You start out with, 3 equations with 3 variables. But then you have to simplify it into 2 equations with 2 variables. So that means, we need to break this down. So what do you think, looking at the 3 equations that you have, which variable will be the easiest one to get rid of?
C.
Yeah, because you can see there's no coefficient on C. You just have a plus C plus C plus C on each of those equations. So that is definitely going to be the easiest one for you to get rid of. So you know what, let's do this on a new board over here. So let's say we had 16a plus 4b plus c, 16a minus 4b plus c, and then we had 9a plus 3b plus c. I think this guy was negative 28. This one was negative 14. And that one was negative 46. Okay, so you should see the new whiteboard coming through. So I want to see how you are going to eliminate your, system down from 3 equations with 3 variables to 2 equations with 2 variables. And if you need help, let me know and I can walk you through. Okay, Connor, no problem. Because would you use the addition or elimination method, or would you use the substitution method to, do the system of equations? Because how would you eliminate the C? Sarah, what's going to happen to your 14 on the other side?
It's gonna be positive.
Yeah, be careful with those signs. So if you're using the addition method, guys, basically you can start with the first 2 equations. So if you want to get rid of C, since you have both of them as positive C, you need to make one of them a negative. So you can decide either to multiply the first equation or the second equation by -1. So that will basically end up changing all the signs on both sides of your equation. And that way you will then be able to break your system down from 3 equations down to 2 equations. You'll of course need to do that one more time with the third equation also. Yeah, very nice, Kayla. So you will actually see once you start adding these equations together. So yeah, Misael, great setup. Now either multiply your first equation or your second equation by -1, and that will help you get rid of C from those first 2 equations. Michael, very good. So those of you who are kind of solving this, you are able to see And I've got a couple of you who've already almost gotten your answer. You will see when you add the first equation with the second equation by making one of those into a negative or multiplying one of those by a negative, you are actually getting rid of more than the C variable. And it helps you find the answer to one of the variables right away. Very nice, Michael. Yeah, very good. Kayla, you actually found the answer to 2 of your variables. You're on your way to finding the third one. Very nice. So, Misael, remember when you are making, looks like you're multiplying your second equation by the negative sign. So remember, all the signs in your second equation will change. So what was positive will become negative, and what was negative will become positive. Okay, Colton, very good. Connor, Elias, Suhani, do you guys need help? How are you doing? Okay, Colton, are you adding your equations? Yeah, there we go. Okay, so Misael, again, on your second equation, change the signs. You haven't changed the signs on all your terms. It should be for all 4 of those terms. Your sign has to change. Okay, Michael, very good. You also got the same answer. Colton, after you eliminated your 2 variables, you have to add the equation. Remember, you're not quite at the division point yet. You need to add your remaining terms and then simplify for the remaining variable. All right, very nice, Kayla. Good progress. Suhani, very good. Okay, Michael, good. Misael, you kind of seem to be stuck at that place. All right, very good, Colton. Nicely done. Okay, let's see what you guys have so far. So you have taken 16a plus 4b plus c equals negative 46, which is our first equation. And we're multiplying that, adding that with the second equation multiplied by negative 1, which will then give us negative 16a positive 4b minus c equals positive 14. And we add these 2 equations together, which will actually help us get rid of positive 16a, negative 16a, positive c, negative c. And you will be left behind with 4b and 4b, which will add up to 8b. And then you've got negative 46 and positive 14, which will end up giving you negative 32 because, of course, 46 is a larger number. divide both sides by 8, and you end up getting b equals, what is that, -4? 32. Wow. I keep hitting that stop share for some reason. So this is where you come up with the b value right off the bat when you do that first one. So this was adding equations 1 and 2. Now you can do this by adding, I don't know, equations 2 and 3, I guess. And I'm still going to leave my second equation being multiplied by -1. So that will again give us -16a, +4b minus c, and +14. Keeping the third equation as it is, 9a, 3b plus c equals -28. We'll add these guys together. So that's -16, +9 will give us -7a. 4b plus 3b will give us +7b. Your c will, of course, cancel out. And then +14 minus 28 will, of course, give you -14 as our answer. You can simplify this equation here if you want, because you can see everything can go into 7 if you want to do that, or you can leave it as it is, it doesn't matter, and then just substitute for the b variable, you know, with -4. So that will be -7a plus 7 times b, which is -4, equals -14. And you can see this will lead us to finding out the a value, which this guy will be -28. Move the 28 to the other side. -7a will be what? +14. And then divide both sides by -7. We end up getting a equals -2. And I know, Kayla, you were the one, we're kind of working with this. So yeah, same thing here. You ended up getting a equals -2. So that's a good sign. So at this point, you can see, as I was mentioning, this is actually a pretty quicker problem because, you know, you ended up eliminating both a and c in that first step. So you've got the b value, you've got the a value. All you have to do is now find c, because, you know, since that's the first variable you eliminate, that will be the last variable you find. So to find the c, honestly, you can use any one of these equations, but I think I'm going to use the last one. So you've got 9 times a, which is -2, plus 3 times b, which is -4, plus c equals -28. So let's see, that will give us -18 here. What will this be? -12. So when we move these guys to the other side, that will be what? +30. So c comes out to be +2, and I'm gonna use Kayla again as my solution here. So yeah, you've got -4, -2, +2 for your, you know, 3 variables. And then remember, guys, at this point is where we go back and finish the 3, you know, a, b, and c values. You put it back into the parabola. So I'm actually going to go back to our initial screen over here. And now that we have our a, b, and c values, a is -2, b is -4, and c is +2. Again, using this equation, you will have y equals -2x squared minus 4x plus 2 as the equation for your parabola. So that's kind of how this system of equations will work out. So let's put that in here quickly. So that will be -2x squared minus 4x plus 2. System of equations, especially section 5.2, is probably one where I would say practice a little bit, you know, get comfortable with that because, you know, that is something new. And I don't know how many of you have actually worked with system of equations with 3 variables, but that would definitely be where I would say practice more time. Remember, guys, you can have your cheat sheet kind of thing with you for the exam. If you're going to be spending too much time looking for answers, searching for answers, then you're going to run out of time. I'm just showing you that the answers we checked came out correct on this exam. So don't, wait to get your answers while you are taking the test. What you want to do is have your, prepare so that you know what your answers are going to be. The cheat sheet is just so that, if you need to know the quadratic equation, you're not having to go, search for it. The quadratic formula, anything that you think might kind of help you so you don't have to memorize it. Those are the kind of things you want to have on your cheat sheet. But like I said, if you're going to be flipping through your notes and your textbook trying to find the solution, you guys are going to run out of time on your exam. So use that practice exam. It's 64 questions, so it may seem like it's a lot, but as I told you, you can just X out of your exam instead of submitting it. So you can keep coming back to it and working on it. So that way you can break your 64 questions down into, 2 sessions or 3 sessions, however you want to do it. And again, just as a final reminder, this is the last week to get caught up on any older assignments that you have not completed. And don't forget to send me your request for the final exam. So next week, guys, on Tuesday, we are doing our first part of the final exam. You will log in like you normally do. Your exam will start right at 9 o'clock. So if you want to come in, a couple minutes early so you can get that full 1 hour. I think I've given you a little bit extra time. So if you want to stay a little bit longer after 10 o'clock to finish the exam, you can. I've given you, I think, 90 minutes or something like that on the exam, but it's an hour-long exam. Of course, if you have other things you need to get to, then you want to use the 9 to 10 time slot as efficiently as you can. So if you want to come a couple minutes early, I'll probably open up our classroom at probably like 8:50, 8:55, something like that. So you can come in, have everything ready. And then what I will do is give you the password for your exam, and you will just put your password in and you'll be ready to get started. Okay. Any questions coming to mind, guys, as we're getting into the final?
So it's open book then, open note?
Yes. Yeah, so you can keep whatever you need. Like I said, if you want to make a cheat sheet, you can, or if you just want to have your notes there with you, whatever you want to do is fine. Just don't waste time looking for the solutions because it really will eat up your time. Okay?
Okay, and just a handheld calculator, I'm assuming then as well?
Yeah, so you can use scientific or graphing, whichever one you are comfortable with.
Okay, perfect. Thanks.
Yeah, no problem. You will need to keep your videos turned on, guys. So just make sure, your Wi-Fi and everything is working well, and there won't be any issues with having bad connection or anything like that. So just, obviously we want to make sure that I am able to be able to see you guys as you're taking the exam. Okay.
Are we allowed to use the calculator on our computer as we're taking the test?
Like a Desmos kind of calculator.
Just like the system calculator that Microsoft.
Oh, okay, that comes on your machine. Yeah, that's fine. Yeah, I think you can change those into a scientific calculator and stuff. So yeah, you should be able to use those.
What did you mean when you said you can come back periodically and finish it?
That's for the practice exam, not the final exam, because the practice, since it's got 64 questions, if you are not able to do it in one sitting, one session, for the practice exam, you can exit out, like X out, close your window instead of submitting your quiz. So that way, if you only got 20 questions done, you can come back and do the rest of them. Because if you submit your quiz, then you have to start from the beginning. But that way, when you're doing the practice exam, you don't have to keep coming back from the beginning. You can do it in one session, but you can break it up into multiple times.
Okay, thank you.
Yeah, you're welcome. A final exam, of course, you guys will have to do it in one sitting. So the final obviously is a little bit different than the practice. Any other questions coming to mind, guys?
How many questions will the first half of the test be, and will it be over specific chapters?
Do you mean like each part of the exam?
Yeah.
They are mixed. So I have taken, so normally whatever my regular final is, I've just broken it up into 2 parts for your class. So I've actually mixed. So you will see all chapters in each part of the exam. So if I had like 2 questions from chapter 7 in the original exam, I put 1 question in part 1, 1 question in part 2. So that's kind of how I've broken it up.
And then how many questions?
You know, let me see, since I broke it up into 2 parts, part 1, will it show me the questions? So part 1 has 13 questions in it, and part 2 has 12 questions in it. Yeah, because I believe my original is 25 questions, so I broke it up into half and half. So it's like 13 in the first one, 12 in the second one.
So I'm guessing that it's not going to go in order in that case.
No,
Like,
because
you would-
remember your exams are kind of, they randomize your questions. So they're just, you know, your first question can be from chapter 1, but then the second one can be from chapter 5. So it will just switch the order around. It does that
Okay.
automatically. Yeah.
Okay.
Any other questions coming to mind, guys? And you know, obviously, you can send me an email later on, or if you want to meet with me, if you need some help with just, you know, anything else, we can definitely do a 1-to-1 Zoom session or anything like that. But just as a reminder, we're taking part 1 on August 3rd, which is next Tuesday, and then we're doing the part 2 of the final exam on August 10th, which will also be the last day of our class. And this Sunday, August 1st, is the very final last day to get caught up on any older assignments. Okay, if you don't have any questions, guys, then good luck. I will see you next week, and be safe, everyone. Take care. Have a great day, everyone. Bye. Take care. Bye-bye.